Disruption has hit the global economy. But this turbulence is nothing new. For many years now, business has experienced a digital disruption. That disruption has now accelerated, meaning all companies must quickly adapt. At Silicon Valley Innovation Center, we've been helping companies innovate for more than a decade. Our leading digital transformation program provides the inspiration and practical learnings executives need to navigate new, fast-changing realities. In live online sessions, program participants connect directly to Silicon Valley innovators to learn the latest digital trends. Hear firsthand experience-based insights on how to navigate disruption and emerge stronger from periods of crisis. Join leading digital transformation and connect to Silicon Valley today.
Hello everyone and welcome to our speaker series. Today we're going to talk about AI and ROI, artificial intelligence and return on investment. My name is Vlas Lezen. I'm Chief Operating Officer at Silicon Valley Innovation Center. We are a boutique innovation and management consultancy and advisory firm here at Silicon Valley in San Mateo, California. We have been providing for more than a decade corporate trainings, advising solutions, and thought-leading events such as this. This event is sponsored by PERSPECTA, one of the leading providers of governmental solutions in the United States. So thank you so much everyone for joining us today, and we have a very packed agenda in front of us. So as you can probably see right now, we are doing the introduction. I have a small interactive session that is going to be just take another 10 minutes while everyone is gathering together. And then we will go to our first speaker, Invision, who is going to have both presentation and Q&A occupied from 12 to 12:40, all times here in the Pacific Standard Time. So in case you're in different region, just adjust your time accordingly. Then we're going to go to the IBM. Then we'll have a 5-minute break. So in case you want to grab a cup of water or a cup of coffee, then we will go into the Cisco. And our last presentation is going to be by our sponsors today, PERSPECTA. Also, please do stay till the end of our program, because at the end, we'll have one more interactive exercise and we will also send you a survey. And for those who completed the 3 surveys, the video that you just saw about leading digital transformation program provided by Silicon Valley Innovation Center, starting on November 30, we're going to distribute 3 free tickets to this program to those who filled our final survey, given the feedback about the event. So please stay tuned, listen to us, and you may win one of the 3 free tickets to our leading digital transformation program. So without further delay, let me switch to actual interactive part, because I understand that listening to the talking heads for 2 hours is not almost the most exciting thing. So how about we do this? How about we add a little bit of the interactivity into our program? So let me switch to a very interesting website. If you haven't heard about it or used it, please go and try. It's super amazing to get this perspective. I know some of you already did, so let me switch to this. So you can go to the menti.com, and I'm going to post it on the chat in our crowdcast. So I'm just going to do this, and I'm going to do that. So please do share your thoughts with us. For those of you on that other platform, you can just go to the menti.com and enter your feedback. So please do that, and we can see already some people are adding about what are the main challenges that their company have for adopting artificial intelligence. So I'll just give everyone a second so everyone can join and just fill it in. So just go to the menti.com, enter the code 2891 513, no spaces, so you can just type it in. and provide some of the ideas that you have about adopting AI. I like that someone have no challenges with adopting AI. That was good. I can see finance is actually quite a common topic here, and I think that this is exactly what we'll try to do today. We're trying to see how we can do this ROI, what the artificial intelligence can and cannot do. There's also 2 questions in the survey, so please do take your time and fill that survey. Yeah, I think general knowledge, I think AI is one of those words that is super popular, and I call them nothing/everything words, right? That they, on the one side, every company, every individual put their own understanding of what the artificial intelligence is, and that's why it becomes a little bit hard to actually dissect it. It's almost like innovation, right? That nobody really needs innovation, because innovation is like happiness. For some, happiness is vacation. For some, it maybe going to the concert. Maybe for some, it's a bottle of wine or spending the night with their partner. So that's definitely something that each company need to understand. What is AI for them and what it can do. So I think we're going to go into the several of the details about how different companies looking into adopting AI and what it can and cannot do. So just giving maybe 2 more minutes for people to fill in. And I also think we have a little bit of the popular culture baked in. You know, when we think about AI, we're thinking a little bit more about Terminator and, oh my God, they're all going to kill us, or it's going to be so intelligent that it will out-intelligent us. So, and I think that we're not there yet. Plus, you know, we're constructing those things, so we can definitely control them. Thank you so much for providing your feedback. I think that breakdown complexity is extremely important, because it can be as complicated or as easy as we want. Sometimes artificial intelligence can be done in the spreadsheets. If you're really just using some of the statistics and machine learning methods, you can start your artificial intelligence journey in the Excel spreadsheets. Oh, this is great. This is great. So again, for those who just joined, you can go to thementi.com, enter the code 2891513, and enter what are some of the problems that your company might be facing with adopting your AI. What stops you from more widespread adoption of artificial intelligence in your organization? Okay, so let's look at the next one. So we also have provided interesting areas that where do you think AI is actually providing the best bang for its buck? When do you think is going to be the most effect of adopting AI in your organization? As you can see, we're all looking into the human resources just got on top, which is really interesting. So that's the second question. If you click on the next question, you might actually see about what goes into this, right? And I think the human resources is actually really, really interesting, especially in the world that we live in right now, where we have so many companies gone virtual. So you're not only competing with your traditional rivalries for the best talent, you're competing with the largest global companies, because they realized that their workforce can work everywhere. Google, Amazon, Microsoft, they're not really bound any longer to hire talent in the United States or bring talent to the United States. They can actually go and hire people everywhere, the best people from around the world. How do you actually cope with that challenge? And can AI help your organization to hire better people. No, this is super exciting to see. And I think back office is a really interesting one as well, right? Because we, for so long, we have been focusing on this sort of automation and using AI to free our workforce to do some of the more meaningful things, right? So I always think that sometimes adoption of AI in the back office can actually lead to the higher revenue on new products, because you can actually repurpose your workforce that was before doing something that was not directly revenue generating, something that was not directly speaking to your value prop, to actually those new products generating revenue or even marketing, as we're going to start with our first presentation from Invision. New products, I think, also is very interesting. I think Invision is really touching. I kind of had a peek on the bullet points of the Invision presentation. I think it touches about how can you create new products and how can you market those new products with help of AI. How can you do something personalized that before that was a very high touch, very white glove sort of approach, but with the AI, you can actually do this in scale. And I think that this is probably the most important thing that AI does, because transformation really does not come from the technology. Transformation comes from the processes. But what AI can actually introduce, it can introduce the scale. It can take something that previously would take a long amount of time to do manually and automate it and do it better, faster, and with the smaller mistakes. So thank you so much, everyone, for voting. We're going to have another one of those at the very end. So let me probably thank you, everyone, for voting. So let's just switch. And we also actually going to share those results with everyone who participated, just because I think it's kind of interesting, and see whether your organization fits with the problems that others sees. Because I think it's really important to understand that some of those problems, and from our business advising Fortune 500 companies, Fortune 2000 companies around the globe, that every company is unique, but the challenges that they face can actually be solved in a sort of very repetitive manner. So that's one of the services that we provide as an advising service, and we actually see that a lot of problems could be solved in the very similar manner, because they're not really that dreading, as long as you break them down to something that can be easily implemented. So thank you so much, everyone who participated. So let's switch to our first speaker, Invision. All right, so our first speaker is Brian Kardon, Chief Marketing Officer of Invision. Brian Kardon is the Chief Marketing Officer of Invision, the leading digital product design platform powering the world's best user experience. At Invision, Brian has executive responsibility for all go-to-market activities, including sales, customer success, and marketing. Previously, Brian was CMO at Fuse, a cloud communication platform. During his 4 years at Fuse, the company grew from 30 million to more than 125 million in revenue. Fuse was named the market leader by Forrest Research, and the Fuse marketing team won the prestigious Serious Decision ROI Award for demand creation. Brian has been named to several new lists: 50 most influential CMOs on social media by Forbes, 100 most influential chief marketing officers in the world by Ricktopia, 30 tech marketing leaders changing the industry by Centizio, and 20 executives shaping the future of marketing by Business Insider. Brian received his Bachelor of Science and MBA degrees from the Wharton School at University of Pennsylvania. So, without further delay, Brian, off to you.
Hello, I'm Brian Kardon. I'm the Chief Marketing Officer at Invision, and it's great to be with you all. And very excited about our topic today, which is all about AI and marketing. And I'm a marketing practitioner for a long time, and we've of course all seen how AI has touched so many things in our lives. And today we're going to be talking about specific examples of how artificial intelligence is being used in modern marketing organizations. First, a little bit about me. I began my career at the bottom of this chart. After business school, I joined a strategy consulting firm called Braxton, which is part of Deloitte. Became a partner there in their consumer marketing and strategy practice. My clients were companies like Heinz and Campbell Soup and Ralph Lauren and Merck. And that was a great, exciting time where we started to see lots of digital transformation going on. And from there, being a partner, we had our first children were born, twins, and the life of a consulting partner is traveling all the time. So I was thrilled that I got a job offer to be a CMO at Reed Elsevier, about a $5 billion British-Dutch company. They own things like LexisNexis, the large online database, Elsevier Science, which are subscription scientific journals, trade shows, a whole bunch of things. I was there for about 6 years. I joined Forrester Research as head of marketing and head of strategy. My first part of my career in software was with Eloqua Marketing Automation, and that was very exciting. It was a small company when I joined, about $15 million a year. We got up to about $100 million a year in about 4 years. We took it public and was acquired by Oracle. Lattice Engines is actually a company that does artificial intelligence for sales and marketing, and I was there for 4 years. It was subsequently bought by Dun & Bradstreet to really marry the data, heritage, and legacy and assets of Dun & Bradstreet with predictive analytics and artificial intelligence. And I've been at Invision now for a little over a year. Just a little bit about what Invision is. We're a digital product design platform. It allows companies around the world to build digital experiences for the customers. We have about 7 million people around the world using our platform. It includes 100% of the Fortune 100. So it's very large companies, but also mid-sized and small. Some of our accounts that we work with are companies that were born digital, like Uber and Netflix, and others, there was a really compelling reason to become digital companies like Goldman Sachs or Bank of America. One of the very interesting parts about our company is we were founded about 10 years ago, and we've always been a fully distributed company. We don't call it remote, we call it fully distributed. And we have 0 offices. We have over 600 employees, and we've never had offices anywhere in the world. And so part of the idea was we help our customers build digital experiences, and we wanted to see what it's like to run a company through digital experiences and not face-to-face experiences. And we have a lot of resources on our website that if you're thinking about, in a COVID world, about being fully distributed forever or a hybrid model, there's lots of things on our website that can help you through some of those issues. As I mentioned, we have 100% of the Fortune 100 and lots of different kinds of customers. Customers like Disney use us for all the applications for like Fast Track and Fast Lane and in-park experiences. They also use it for different kinds of applications in animation, customer experiences. In the case of some of these service providers like WPP or PwC, they use our platform on behalf of some of their customers to build digital experiences for their customers. And as a platform that allows people to build digital experience, we have the design piece where you can design experience. You can share that prototype with other people. Then you can send it over to your front-end developers who actually write code and build it out, and you can scale it across the organization and get other people to comment and talk about it and eventually ship that digital experience. So let's talk a little bit about AI. I very distinctly remember this moment. Do you remember the name of the player in the middle? That, of course, is Watson, who beat the player on the left, Ken Jennings, who I believe to this day is still the greatest human player. But for those of you who love Jeopardy, it's a game that is very hard to program. It's not as simple as searching for very objective information, like how many humans are on the Earth, or answers to equations or specific answers. It's a very challenging problem that IBM through Watson has been able to solve. When I went to business school, a lot of my colleagues wanted to be traders. And now we see that as a career that human beings don't do, but bots do. So the algorithmic trading that happens now, the algorithms don't just tell what trades to make, they actually execute the trades as well. And so the human beings are very much employed in this process, but they're writing the algorithms and they're writing the code and using artificial intelligence to place optimal trades. Has anyone ever been in an autonomous car? These are a lot of fun to be in. Can be very frightening as well. I've been in an autonomous car a couple times, all in San Francisco, and it's just really fun. We went on the 405, so I remember leaving Google's offices and getting on a ramp and getting on the freeway there, and the car performed flawlessly. Curiously, when they brought the car to the East Coast, I live in Boston, and they brought it to the East Coast in January, and despite having hundreds of sensors and cameras, the car did not know what snow was. So when it came to a little wall of snow, a couple of inches, the car would stop, assuming that it was not a material that you could drive over and crush. So the car had to learn about different weather conditions, which I find really interesting. All of our lives have digital assistants, Alexa and Google and Siri, that are parts of our lives naturally. One of my favorite examples is there's a Sundar from Google, and he wants to make a haircut appointment. And it's not simply a matter of asking his digital assistant to put it on his calendar, but the digital assistant actually finds the hair salon, goes through his contacts, finds the hair salon that he always goes to, finds an available time, places the call, and uses a voice to actually interact with a human being at the hair salon and book an appointment, put it on his calendar, and confirm it. It's quite striking. There's the URL if you want to watch the YouTube, but it's a great example of humans and AI working together in a very effective way. And we, of course, we live in a world powered by AI in all sorts of areas like healthcare, insurance, credit cards, retail. It just seems to permeate almost every field. Today, we're going to talk about marketing and sales. So let me give you a couple of examples that we believed 5 or 10 years ago were going to be bright spots for artificial intelligence in marketing. The first area is smart lead routing. So lead routing is when you have a lead, and the idea was I'll route it to the rep who has demonstrated the highest ability to close a lead like that. So let's say it's a healthcare company that is a lead, and you know that Nancy has the highest close rate in the healthcare sector. So the leads would be routed to the rep there. A second example would be content creation. And can artificial intelligence identify the kinds of content that you should be creating on your website to drive engagement? What are the topics of most interest? And the third area that held a lot of promise was predictive email. As you might expect, we have lots and lots of history of when people open email, when they click through. Is there an optimal day and time of day that you send email? Not to everyone, but to a particular person based on their history. Can you build artificial intelligence that will yield higher open rates based on when people historically have opened emails? And so in all three cases, they have failed. So I'm going to, in a couple of minutes, give you some examples of things that have succeeded. And these have failed for a number of reasons. In most cases, it's lack of enough data to build a model that is robust enough that it would yield higher results than would happen randomly. So these three examples, while people believed 8 or 10 years ago were very promising, have not proven to be very helpful. So let me talk a little bit about what a lot of marketers say. They say that we're now modern marketers. I'm particularly talking about B2B, business to business marketers. But the data would suggest otherwise because the results are quite poor. So what's wrong here? MQL stands for marketing qualified leads. So the marketing team spends a lot of time and gets a lead. Someone comes to the website, engages with some content. They pass that lead over to a BDR, a business development rep, or a sales development rep, an SDR. But in fact, from all the data across thousands of companies, we see that 94% of all, quote, marketing qualified leads will never close. And so if I was on the receiving end of those leads, I probably would not follow up very well, because only 6% are going to close. That doesn't seem like a very healthy rate. And that rate has been pretty steady over the last 8 years. So we don't see a lot of improvement despite all these marketers being modern marketers. The second area in a related function to sales is that, according to the data from Gartner and Serious Decisions and Forrester's, 52% of sales reps will not make quota. So here you are, do a lot of planning, and yet barely half of your reps hit the number that they're assigned. Huge failure. So both the MQLs are not converting at a healthy rate, most will never close, and just about half the reps are not hitting quota. So I'm going to suggest today that there's a better way to do things, sort of next-gen marketing. This era of modern marketing happened because of marketing automation and scaling. Things like Eloqua, where I worked, or Marketo, but there were new marketing tools that allow marketers to automate and scale. And there are additional tools now with AI that allows marketers to move from poor performance to extraordinary performance. I'm going to go into some detail about these. William Gibson, the writer, said famously that the future is already here, it's just not evenly distributed. The point being that we're seeing some organizations applying AI very effectively in marketing, and other organizations either not applying it or spending a lot of time and cycles and effort and money, and it's had disastrous results. What we're seeing is that if you are very clear about what job you want to get done, there are very specific AI-powered tools that will allow you to get there. Let's talk about them. So the three examples today will be, first, identifying target accounts. Most marketing and sales organizations have a huge universe of potential target accounts that they can go after. What if you could apply AI to identify the accounts most likely to buy from you? So it gets to use AI to disqualify tens of thousands of accounts that you should never call because they have a low conversion rate. So how would you do that? The second example is engaging with prospects at scale. So if you have lots of leads coming in and you only have, let's say, 20 or 30 humans to pick up the phone and follow up, you may not be able to follow up in a timely manner. So can you use bots? Just like Sundar used a bot to make that haircut appointment, can you use a bot to engage with a prospect, qualify and disqualify, and do a lot of the work that normally a human being would do? And the real advantage here is speed of time. Very often with leads, they don't come in an even way, but there could be a spike of leads. Let's say you run a big webinar and you get 10,000 leads one day, and you have a modest-sized team. They can't work through the leads in a timely manner. And we know that the decay rate is quite fast and steep for leads if you don't respond right away. And a third area is improving conversion rates. One area of marketing that's been particularly impressive is, believe it or not, direct mail. So everyone sort of leaned over to digital communications, but we're seeing that if you mail something to a prospect, you have a much higher chance of having a meeting with them, that they feel somehow beholden to you because you sent them a gift. And so I want to talk about AI gift giving. Is there a way to scale that rather than have all these sales reps trying to come up with a gift that's either personalized, or you just send everybody the same gift, which would have a low conversion rate? How do you personalize a gift at scale? So let's talk about these. The first question is, which accounts are most likely to buy from a given company? And so this is the target account question. And so what we've done is we've looked at, we've done a back test. We've looked at 2 years of account history to identify accounts where we've won and lost. And then we've appended a whole bunch of additional attributes to those accounts to build out a very robust data set. And so basically it's a multiple regression. We run a model to identify the most predictive attributes. And then we acquire accounts that have those attributes. So for example, if we find here that the tenure of the CIO, one thing we found in this example is that during the first 6 months of a new CIO, you have a much higher chance of having a meeting with them and a much higher conversion rate. Once a CIO has been in their job for more than 6 months, they're sort of locked and loaded, and they're much less open to talking to new vendors. So we would append that information to the data set, and we would look for other accounts like that. So in this particular case, we found out that there was an ideal company size. Companies that were smaller or larger had a low conversion rate. Certain industries, the existence of certain technology was predictive. So you may ask the question, well, how could I possibly know what technologies companies are using? There's lots of good ways to do that. One is scraping through their job descriptions. So if you scrape through a lot of the job descriptions, you'll see that what technology they're using. In this particular case, we found that multiple locations was much more predictive than a company that had one location, global presence, and some other on-premise systems. We identified almost 22,000 accounts. We assigned accounts to RSMs, regional sales managers. Then we got contacts at those 22,000 accounts, and we started running ads across all of those accounts and across all of those contacts. What's important is it's only 22,000 accounts. In this particular case, they started with an initial list of over 200,000 accounts. So they pared it way back, less than 10% of the accounts. That allows them to have much greater presence and more marketing there. The BDRs, a higher rate of calling target accounts. It began, when this program began, only 59%, and then it went up to 84%. And these are maps of where the target accounts are located. One of the great benefits of understanding where your most likely accounts are located is you can put local events in those regions. For example, if I get a call from a rep in Nashville that would say, Brian, could you run a dinner or a special program here in Nashville? I would look at these data and I'd say, I don't have enough target accounts in Nashville. Why don't we do it in another city? Let's do it in Houston, or let's do it in New Orleans, or let's do it in Miami. That has a much greater density of target accounts. And so what were the results of using artificial intelligence to identify target accounts? Well, the first area is cycle time. The non-target accounts were closing in 205 days, the target accounts in 140 days, a dramatic difference in cycle time. The deal sizes were also quite a bit larger, and the win rate from opportunity to closed won was up quite a bit. And so these are very dramatic results. And the whole idea was to focus on fewer accounts that we knew, based on a back test of looking at historical data, were much more likely to close. And so the win rate we could have expected. The deal size is something that was a wonderful side benefit, and the sales cycle time was fairly predictable. So that was target accounts using predictive analytics. Let's talk about the second application of AI in marketing, engaging with prospects at scale. Sometimes marketers and salespeople have the curse of abundance. And what that means is they just have too many darn leads. And how do you decide which leads to follow up with? The example that I gave earlier is very relevant. Let's say you go to a trade show and you get several thousand leads. We know that responding to a lead promptly really matters to conversion rates. And very often human beings can't respond quite as quickly as artificial means. So our BDR team, the business development rep, this team is responsible for calling the leads, following up on the leads. The first challenge is lead surge. So if you have a big spike, a surge of leads, how do they follow up with very promptly? The consistency. So the BDRs are human beings, and we wanted them to have a cadence of 7 touches, 2 calls, and 5 emails, but we had no way to guarantee that. And we wanted fast follow-up. So here's some data that talks about dials and response. And you can see that if you respond within the first 5 minutes of someone indicating interest, you have a 10 times greater chances of engaging than after 10 minutes. And you can see even after 30 minutes, it falls. And so how do you do this very quickly? How do you respond to leads very quickly? Human beings can't do that necessarily. And so can you automate this in some way? And so we decided to use a bot, and her name is Natalie. We called her Natalie because our best BDRs at our company are women. And so we wanted to use a female name. And so Natalie really never needs time off. Natalie doesn't take vacations, no sick days. Natalie also can respond at 2 a.m. or 11 o'clock at night. And Natalie responds in a very consistent way. And so the BDRs were telling us they can't always respond as fast as they like to a prospect, but a bot can. And we've seen that bots, the intelligence you can program into the kinds of conversations you have really are as good as human interactions in email. Now, Natalie cannot do phone calls just yet. Only humans do that. We're working on that. But Natalie is extremely effective at sending out very effective emails, personalized emails, and even using things like Calendly to schedule appointments with a rep. So very high conversion rates and great engagement rates from Natalie, the bot. The third area we want to talk about is gift giving, which we've seen to be quite effective at converting prospects. So trying to get a meeting with a C-level person is extremely hard these days. We have all sorts of blockers on our phones. We have ways to put into junk mail email from people we've never heard from before. So email has extremely low conversion rates. Cold calling is extremely difficult. One area that we've seen work pretty well is direct mail. We've seen, all of us have probably received a bottle of wine or some sort of generic gift with a note. What we've seen is that if the gift is highly personalized, the conversion rate and the receptivity of the recipient to engage with the sales rep is very high. So when I learned that personalized gifts, when we sent them out, were very effective, I asked our BDR team to start going into Facebook to start looking at prospects' profiles to try to come up with a personalized gift. Now, the downside was, I remember a week after I talked to the BDR team about doing this, I walked over to where the BDRs were sitting, and they're all on Facebook all day, like writing down things they saw in pictures and profiles. And this person went to Notre Dame, sent him a Notre Dame, hat and a sweatshirt. So they're trying to personalize gifts. So how do you do this at scale? And there are tools to do this. I'm going to talk about one. This is one where if you give this tool, the tool's name is Alice, A-L-Y-C-E. If you give Alice a business email address, it will match that email address with the social profiles of that person. So if you give it my email address, there's me, Brian Kardon at Invision app. It'll find my Facebook, Instagram, Twitter, LinkedIn accounts. It will then crawl through my profiles, and using its logic, its AI, it will make specific personalized gift recommendations. And they will actually send out the gift, or they'll send out a card that says a gift has been chosen for you. Click here with a PEARL, a personalized URL. So here's what really happens is the bot goes out, and this is an actual picture on my Facebook account, and it sees that I have a new dog. And it rated this picture very high because of the number of likes that it had, and also that I'm with my 2 children, my sons. And so the bot found images that would suggest that maybe there ought to be a gift related to a new dog. And it also found this photo. I'm there with my son and my wife, and we're actually at an opera house. And the software was smart enough to know that it was an opera house, not a movie theater, based on those balconies, based on the architecture. So it knew that this was an opera house in Prague, in the Czech Republic. And so it recommended 2 things that were personalized. One is a bark box, which is a monthly box of little treats and little toys for your dog. And the other was a coffee table book on the most beautiful opera houses of the world. So highly personalized gifts, and it was just wonderful. And as I said, Alice, the software actually will send out the gift automatically, or at least a card that says the gift has been chosen for you. And the conversion rates were quite high. So in our world, NBM means new business meetings, and that's a stage in our process. And we did a proof of concept where we had good conversion rates. And then we tweaked along the way a personalized note and some other things. And we had amazing results. So we sent about 2,000 gifts in this test, and we closed 8 deals. And the average deal size, the ASP, was $250,000 a year, so about $2 million in new bookings. And the cost of this whole program was only $25,000. So personalized gifts at scale. If you tried to send out 2,000 personalized gifts and you let human beings pick out the gifts, it could take thousands of hours for people to find all those gifts and personalize it. So this was extremely effective. So today we talked about 3 applications of AI in marketing. The first is target accounts using predictive analytics. The second is following up leads with a bot, Natalie. And a third is choosing gifts at scale for a direct mail using AI. So what's been the cumulative result? I've masked a little bit of this data in the vertical axis, but basically the sales rep productivity gains over this period that we applied all 3, they've more than doubled. So if the MRR, which is monthly recurring revenue goal, was $800,000 per rep, the quote actually went up to 1.6 million. It doubled based on the value of all of these tools. I want to sort of conclude with some thoughts about AI in marketing and what we're seeing across a range of organizations. And I think one of the conclusions, as William Gibson said, is that if you apply it the right way, you can have extremely beneficial results. But also for a lot of organizations, it's been a time sink. So you have to do it in a way where you know precisely what you're trying to get done. But I think AI is becoming something that we've seen through these decades. I'll give you a few examples. If you are old enough to remember the 1990s, every company in the world wanted to be a, quote, .com company. And of course, every company is now. And so the word .com sort of goes away, and every company is a digital company in some way, even companies making physical things. Think about GE making big engines. They have sensors on their engines. They have ways to track performance. Companies making drugs, they become digital companies as well as people order prescriptions. In the 2000s, every company wanted to be a cloud company. And so people were bragging that they were cloud first, they're a cloud company. And now that's pretty much gone away because every software company is a cloud company. The third area, and I remember this very clearly, was the era of big data. So obviously with social platforms and email and sort of back-end tools, we're seeing the era of big data. Billions of bits of data are now coming out. And every company was going to harness the power of big data. But big data is no longer something special, just like .com, cloud, and big data. It's become in the background and it's assumed. I think the same is true of artificial intelligence, that just like every company became a .com company and every company is putting their technology in the cloud and every company is using big data, every company in some way is an AI company as well. So I want to thank you all for being part of this presentation. And I hope to meet you soon in person once COVID's gone. Thank you very much.
All right. So we have Brian on the line and ready to answer all the questions you might have. So without further delay, Brian, off to you.
All right. Great to be here. Thank you.
No, thank you, Brian. Really, really interesting presentation. Really amazing. But while our audience is getting ready for it's actually I was going to say, while we wait for the questions, there is actually a very interesting question that came from Puneet. He's saying that, pardon my use of words, but are all of those specialized AI tools making the human aspect of sales and marketing dumb? So do you think that there is I guess it's even the bigger question in marketing and sales. Do you think it is more people driven, or it is more sort of like statistics and funnel driven? So what is your experience now?
I'm trying to sort of parse that question. Marketing always talks about left brain. It's about logic and AI and data. And the right brain is being storytellers, telling a narrative. And I always found the best marketing has both. Like, I've had too many marketers look at the open rate, the click-through rate, the conversion rate. But what drives that? a great subject head, a great message, a great first sentence, and so I think you really have to get the messaging right. As far as, I think in my presentation, I talked about it's not the bots versus human beings. It's like, how do we make human beings more effective? And as you said in your opening presentation, how do we parse out the repetitive, consistent tasks that are better served by machines, and to have the humans focus on things that humans are much better at: creativity, building relationships, those kinds of things. But if I were starting my career now, I would probably not choose to be a salesperson. I do think it's one of those careers, think about travel agents, I think real estate brokers are going to go out of business soon. I think about stock traders. I do all my stock trading right here. I don't have to talk to a human being. We do so much on here. And one of the most surprising things, of course, is that a lot of people prefer not to actually talk to a human being. I'm enjoying talking to you, for example, but if I want to get something done, maybe I'm better off just working with an app. And so we got to let humans do what humans are really good at, and let the machines do what they're best at.
Yeah. So it's actually, we have a follow-up question on that idea. So are people able to distinguish between bot emails and human emails, and does it actually turn them off? Do you have any kind of, I guess obviously the answer is it depends how good your bot is, but in general, do you think that people can distinguish it? Do you think it's a disadvantage versus that lead time that you showed, the response time?
It's a fascinating question, because I've done testing on this and I have an answer for you. The first question is, should the bot pretend to be a human being, or should the bot reveal, like, my name is Natalie, and I'm not a human, I'm a bot, but I'm here to help you? There's a certain vulnerability and authenticity about revealing that you're a bot versus a bot trying to simulate it, And so we've actually found that when the bot reveals that they're a bot, they have much better response rates. It shows an authenticity, not just responding to the email, but responding to the company. Your perceptions of the company are that it's a more transparent, easier company to work with. It's like sometimes I'll try to do something with like an airline, and they say, we're looking up your records right now. And you hear like someone going on their computer, like this fake sound. You know what I'm talking about, right? Looks like they're clicking something. There's no one clicking anything, but it's one of these things. And I'm sure they've done A/B testing on it, but I find that very inauthentic, and I can't stand that experience. So the best experience for our bot, Natalie, is that Natalie reveals that she is a bot, but she's here to help, and she works 24/7, and she's here to help, the person.
No, that's I think very interesting. We know on our previous event, when we were talking more about technology, they actually showed that a lot of bots can cover about 97 to 99% of all the inquiries that come to the website, because they not really serve as a replication of the human person. They sort of give a better guidance and better access than just regular, browsing the website. And I think that the people are totally fine with it. And as you said, some people actually hate talking to people face to face. So that's also very, very interesting. So another really, really interesting question, and I think that what I found really interesting about your presentation is that you never really actually talked about technology. And I think that this is a very powerful message, because what you said with accounts, you do not really need, any kind of fancy AI. You just need to, as you said, multivariable regression. You just need people pretty much knowing and being able to collect the data. So the question is that how can you actually build a sort of fast track to the AI in your organization, maybe even legacy organization? Because, when you go to the legacy organization and you tell them, oh, we're going to do artificial intelligence, people can't get good. No, it's all going to kill us. How do you actually make your organization more AI friendly?
Yeah, it's a great question. I think starting really small. I've seen these big initiatives for AI. It's like on your printed, laminated card. This is one of our big initiatives of the year. Those almost always fail under the weight of the pressure. And so starting small, what I've done in previous jobs is I would go get a graduate student, a PhD student, who's really good and knows all these multivariate techniques and studies operations research and statistics. They would use some sort of simple statistical package. I remember when I was in school, SPSS was the hot thing. Is it still in use? Do people still use it?
No, I know because I led a data science team back in Goldman Sachs, but so I know about it. But no, I think majority of people are using like Python and Skate and Keras and all of those.
Right. So there's a whole next generation that are very user friendly. So in many cases, you don't have to know the underlying math. You have to know which sort of techniques to use for different applications. So I found graduate students to be very friendly. They're looking for projects. They're looking for ways to get application of what they're learning. And so And also, rather than talk about a big AI initiative, to talk, what is the problem we're trying to be solved? Like they start with AI as opposed to, we have a challenge here. What are the different kinds of solutions? Oh, AI is a very interesting way to do that. So you prove through very small successes that AI can solve a problem very successfully, and then you sort of go out from there. I think it's concentric circles. I just seen too many failures where CIOs or CEOs saying, we will be an AI company, and they just fail very quickly.
Yeah, I think you are absolutely right, and I also always say that the real change comes from the processes. If a person can generate the value, doing pretty much something in Excel or on the piece of paper, and it still generates the value, when you pour sort of this magic dust of AI, that's going to take this process and just make it at scale. If this process does not work with one person doing maybe one company or two companies at the time, then it will not work on the scale. So I think
Yes, exactly.
it's very very important to build those concrete circle, as you said. So maybe the last question, just being cautious of time. So how do you think companies can increase, and that's going to be a repeating question in our event today, how do you think companies can increase their return on investment on the artificial intelligence?
Yeah, I think I always found experimentation to be a really wise thing. Too many people spend years building something and it's very binary. Either it works or it doesn't. And there's a lot of prejudice. The people involved with it so want to make it a success, and they just continue, and they, not that they falsify the data, like a clinical trial where it's, fraud, but they really believe in it and it goes too far. And so I'm much more comfortable with iteration. Let's try something small. Let's get success. Let's build on it. Just like now with the agile development of applications, like you don't have to spend years building something. Let's build a small prototype, get it in the hands of some customers, see what works, what doesn't, iterate. Just like A/B testing. Let's test 2 different offers, 2 different pricing. Before we roll out new pricing to 1,000 customers, let's try it with 5 or 10 customers. So I think small steps is the way to go, and to iterate and to prove value along the way.
Perfect, Brian. Thanks so much. I kind of echo that idea about always saying that in the modern world, we have so much more objective data, but sometimes getting to that objective data takes a lot of subjective decisions. And I think it's really important to be able to tie all of those things together and be almost comfortable with uncertainty. That, previously in marketing, you say, oh, this works. And now I think it's with AI, it's shifting towards, we don't know. Let's try. We're comfortable of not knowing it. Let's try. Let's see, and then we will make objective decisions versus trying to argue to the end of the world about who's right and who's wrong. Brian,
well, one quick example is, I have a marketing team that's always running campaigns. We run hundreds of campaigns, and no one likes to admit that a campaign's not doing well. But by definition, only half are above average. All of us believe our children are all fantastic, but half are below average. Like somebody's below average. And so you have to really, treat it that way and be very data-driven about what's working, what isn't, and to drop things that aren't effective. But thank you very much. Great questions from your audience. Appreciate
Thank you, Brian. Thank you so much. True pleasure. Thank you so much, and hope to see you soon. Thanks so much.
You will. Cheers.
Thanks. So our next 2 speakers are from the IBM. We have Carmen-Gabriela Stefanita and Aakanksha Joshi. Carmen-Gabriela is a part of the IBM Data Science and AI Elite team. Carmen leveraged her mathematics and programming background in Bayesian inference, hierarchical probability models, and constraint optimization methods to build models that are relevant to her client. A resourceful, strategic thinker, Carmen has the ability to interface with resources at all hierarchy levels and across professional disciplines. She is also an author, inventor, and entrepreneur with a PhD in physics, in stochastic error analysis, and instrumentation development. Aakanksha is a data scientist in the data science and AI elite team at IBM. Based out in New York City, Aakanksha works with enterprise across industries to address some of their biggest business challenges using data and machine learning driven solutions. She holds a master's in data science from Columbia University and a bachelor in computer science from University of Delhi. She has presented at prestigious conferences such as EuroK and is an open source contributor. She is also a strong advocate for ethics in AI and has participated and led initiatives around the same, both within and outside of IBM. Without further delay, I'm switching to Carmen-Gabriela and Aakanksha.
Hello, everyone, and thank you for the kind introduction. I'm Carmen, and I'm very happy to be here today and to talk to you. Because there is no standard practice of implementing artificial intelligence or AI in short, in the business applications that companies have, they may find themselves at risk when they try to use AI in their projects. So they need some help. And for this reason, IBM has created a unit I am also part of, a unit we call Data and AI Elite. And we assist companies with adopting artificial intelligence, scale AI within their business units, and then we help them continue to innovate. But each company is in a different stage in their journey. So with some guidance from our Data and AI Elite team, we can help them achieve their analytic goals, whether they are just picking up data science or are already deep into their analytics journey. So who are we? We are a team of data science practitioners. We have diverse backgrounds. We have worked in different companies, in different industries. And we have also specialized in a variety of AI techniques. So what I like most about working in this team is that we bring in unique perspectives, and they're based on our experiences, on our previous practice. Different points of view are being challenged, and we're actually going to touch upon this in more detail a little bit later. So, together with our clients, we explore new venues of transforming business with AI as we work side by side with our clients. Aakanksha, what is your take on our approach, and what do you like most about this job?
Thanks, Carmen. So if I think about it, I think one of my favorite things about this team and the work that I do is the design thinking mindset that I get to share with my clients. It was as part of this team that I realized that success is not just about solving any data science problem. It's about identifying the business challenges and the biggest pain points that a team is facing, and then build a data science solution that can address those business challenges and those pain points. And that is what can give a real return on investment to the enterprise that is trying to adopt AI. The second thing that I really like about working with the team is the collaborative attitude. So for the period that we engage with any client, we try to spend as much time as we can working together to build a solution, and also do transfer of knowledge so that the client can then take the solution and build it on their own after we disengage. This co-creation model helps me form real connection with my clients. And that, combined with our agile AI methodology, helps us provide real value to businesses. Carmen, would you like to talk a bit more about our agile AI methodology?
Sure. Thank you, Aakanksha. Speaking of agile methodology, for those who may not be too familiar with this, let me explain a bit. And this is also based on my previous work experience prior to IBM. Many people may know of the waterfall software development system, where phases occur in sequence, and each phase depends on the deliverables of the previous one. But this is inherently not a very flexible approach, because progress would flow in one direction, hence the name water flow, flowing downwards. Reality is, it is better to work cross-functionally in a collaborative manner. Here, in our data and AI team, my colleagues and I iterate through a phase of a project that we call a sprint. We're aiming for a proof of concept at the end of a total of 3 sprints. And during each sprint, we revisit our understanding of the business problem, sometimes even the engineering of the data features based on the data that's being presented to us. And then we have a first pass at training and testing our models. I love the fact that by having these iterative cycles, I can be more creative and have a faster pace for solving problems. This way, if my colleagues and I can explain as much as possible the variance in our data, we're done. But if we run into roadblocks when looking for a signal among the noise in our data, then we can include new insights from the business. And then we begin to perform feature engineering all over again before we finally continue with the cycle of building the model. For example, some use cases I have seen that our clients encounter often are around text analytics. And that's because we generate so much data on various platforms, and a lot of this data is unstructured as a result of surveys or other text comments. So AI can come to the rescue to offer some insights. I will ask my colleague Aakanksha to share her experiences and walk us through the process of building an AI model for text analytics. Aakanksha, would you like to explain to the audience how we do this?
Sure, thanks, Carmen. So over the past few years, we have worked with clients across multiple industries like financial services, automotive, and industrial to solve problems like call center analytics or intent identification or survey analysis. Even though the industries differ and the use cases might differ, we have developed a tried and tested methodology that we can now apply to any text analytics use case that we come across. Let me walk you through that. The first step in the process is to acquire data. Of course, there can be no data science without data, right? So we need to get the data. This can be done by connecting to databases that might reside in client environments. This might be scraping data from the web if that's part of the problem that you're trying to solve. Or this can be bringing together multiple CSV files if they have the data. The point is to bring all the data together so that it can be analyzed. The next step is to explore and enrich the data. We need to identify the initial structure that is present in all of the text that we have. We can use methods like latent Dirichlet allocation to see the overall distribution of the data. At this point, I like to bring in a subject matter expert who can look at all of those different word clouds and text distributions with me and tell me what they think those distributions mean. I, as a data scientist, can try to guess what they might mean, but it is the subject matter expert who can say with some amount of certainty that this group of words appearing together definitely means that it belongs to this subject. And so once we have those labels provided to those groups of words, we can feed that information back into the main data set and call that an enrichment, which is embedding some kind of subject matter expertise into the data. The next step is to explore it further. This can be by building visualizations, by building more word clouds. The core idea is to get a real understanding of what there is in the data that we want to analyze. Of course, all of these steps need the right methods and the right tools and techniques, because this exploration forms the foundation of the analysis that we will be doing. Carmen, would you like to weigh in on this process so far?
Thank you, Aakanksha. Yes, of course. You need the right tools to transform the client's business with AI. Therefore, when I engage with a client, I often ask them if and how they use AI in their business, just so that we have a shared understanding, a common starting point. Many people think AI is magic, which of course is not true. So together with my colleagues, I like to start by explaining how AI may fit into their business. Basically, analytics is just a tool that an enterprise would depend upon to make decisions to drive their business. So we would first go through a proof of concept phase where we show how machine learning models learn from historical data and based on that make predictions. This phase is always necessary because it helps establish a scientific process that ultimately leads to the predictions that we seek. Once that is accomplished, only then we can move on to a second phase, which is that of developing a minimum viable product. And we love the fact that we have the opportunity to first explore the proof of concept phase in the project.
Thanks for weighing in, Carmen. So as we move into the analysis phase, let's also talk a bit more about what differentiates the proof of concept from a minimum viable product. So far, we have explored the data, we have done some feature engineering, and now we are ready for the modeling phase. In this phase, we try to develop some supervised machine learning models which are predictive in nature. So based on the historical patterns that they learn, they can predict those values for new text that comes into your process. This can be predicting the labels from the unsupervised methods that we used in the previous step. Or this could be predicting something like priority for call center analytics. The idea is to train a model on historical signals so that it can learn from those and make predictions for your future data so that you can be more proactive in the problem that you're trying to solve. Then once we have trained the model on some training data, we want to evaluate it on unseen data. And if this model consistently performs well on unseen data, and it is something that is helping us solve a business challenge, then we can say that our proof of concept was successful. Now, how do we take this to the next level for a minimum viable product? The first step in that would be to deploy this model into production so that it can be used by downstream applications. Once the model is deployed and we know it's ready for use, we move to the final step, which is an application. We know that in most business scenarios, the end user of the model would need it in a way that is consumable. That way is through a dashboard or an application. Basically, any kind of easy to use interface which can allow this user to interact with the model and get the predictions without having to look at what's going on in the weeds of the deployed model. This application is what we would call a minimum viable product. And if the end user is happy with the results that they are getting, then the enterprise can continue iterating upon this product to make it even better for their end users. We, as the data science elite team, try to not stop at just implementing this for one client. As we get success in the field, and as we improve these tried and tested methodologies, we are now trying to package all of this into what we call industry accelerators. Carmen, would you like to share a bit more about industry accelerators with our audience?
Thank you, Aakanksha. And yes, of course, like you said yourself, what's great about this job is that our team's focus is on outcomes. So my colleagues and I have some common use cases that we have already solved in our practice and that we can adapt now to a new client. We call them industry accelerators because they are AI solutions already developed or under development. They're categorized by industry and are meant to accelerate business. So all we do is just feed in new data from a client into an accelerator. We tweak a little bit the algorithms to customize them to our new client's needs, and we can therefore adapt them to our client's use case. For example, in addition to text analytics, another use case I see quite often these days, and that's calling for artificial intelligence solutions, is around supply chain management. This is because the current health crisis has altered the way we consumers do business or companies do business with each other. The suppliers of products we buy have to alter how they address these new needs. Their old inventories may no longer cover the current demands, but at the same time, goods need to move to make space for new ones and continue the supply and demand sales cycle. So this situation calls for some creative ways of modeling. We may have to move away from some of the more traditional time series models we are accustomed to. And we have to embrace models such as neural networks or reinforcement learning because they can deal with challenges that are associated with very little historical data, or they can focus on a narrow range of products that are in high demand. Aakanksha, would you like to add some other examples you have seen in your practice?
Sure, yeah, thanks, Carmen. So when I look at the portfolio of industry accelerators that we have created so far, I see two distinct kinds of accelerators, and I can talk a bit more about both. The first kind are accelerators which are domain specific. These solve a business challenge which you would generally see in a particular domain only. So an example of that is sepsis prediction in the healthcare industry, or intelligent maintenance in the manufacturing and distribution industry. These are focused, laser focused on solving that specific challenge for that specific industry. The second kind are industry accelerators, which have been built for a specific industry, but the kind of concepts that they use and the kind of use cases that they address can be found across multiple businesses and multiple industries. Some examples of that are text analytics that we just discussed, and demand planning is another one that I can think of. So our demand planning accelerator has been built for the energy and utilities industry. But the underlying concept of combining forecasting with decision optimization to get a best recommended plan is something that resonates with clients across industries and businesses. Anyone who is trying to solve a demand planning use case. And for me, this idea that something can scale across businesses and industries is really powerful.
By now, you're wondering how you can get in touch with us or how you can work with us. So here's a link to request a complimentary consultation. And also, you can get in touch with us and learn more about us at the other link DSC community. We thank you so much about being here today and listening to us, and hope to hear from you very soon. In the meantime, we're open for questions. Thank you, and thank you, Aakanksha.
Thank you, Carmen. Let's have some questions.
All right, so that was presentation by the AIBM team, and we have them on board ready to answer several questions that you have prepared for them. So without further delay, I'm switching to Carmen and Aakanksha. Hello. Hello.
Oh, hello, hi.
Hi. Thank you so much for this presentation. Definitely a different view, and I think it's really important to be able to sort of break it down to the process, right? Because I think that, again, AI, sometimes people think, oh my God, the Terminator, AI, something Terminator is going to be the end of the human race just because it's artificial, it is intelligent, right? So I think it's very important. But our audience actually on several platforms asked a very valid question, and something that ties to your bio, Aakanksha, I guess, is that what is the boundaries for that AI, right? Because when you collect so much data about your customers, or maybe about your partners, that it sort of becomes a little bit creepy. Where do you actually draw that boundary, and how do you actually protect the data? Because you might be using it for completely good purposes, but then there might be some people who might want to weaponize it, not necessarily in the kind of destroy and kill session, but maybe use to sell some scammy products or something that is suboptimal. How do you actually draw the balance about acquiring the data, storing the data, and sort of protecting the data from maluse and general strategy about it?
Sure. So I think I will break down my answer to that question into a few parts. The first thing that I want to start with is the fact that machine learning models and AI models in general are built for generalization. So if your concern is that this model has a lot of data about me and it can use that, that shouldn't be the primary concern. The model learns from patterns which are repeated over distributions. So it'll learn from not just you, but people who are like you. And so if a model is built the right way, it shouldn't be causing any concerns for your privacy. One. Now, with that in mind, there are a lot of questions that need to be asked at each stage of the machine learning pipeline. So if we look at data acquisition, when you start collecting data for any business use case, you should ask yourself questions like, what am I collecting this data for? What problem am I trying to solve? If this is the problem, what kind of data do I need for that? Do I need this person's private information? Like, do I need their address, or can I just work with their zip code? Can I generalize it to a zip code or a county level, as an example? So at the data collection level, that is one way we can protect some of that personal information. Now, if we move to the model building and model monitoring side, then sometimes the data we collect can have some inherent bias in it. The models are built to learn patterns, and sometimes they end up learning some of that bias as well. We need to ensure that whatever models we have running in production are first monitored in a way that they can tell you when a model is making a decision that is unfavorable towards a certain group. And once we cross that bridge, we also need to make sure that we have something in place that can help us explain the decisions that a model is making. And from IBM's side, we have a solution called Watson OpenScale, which we have worked on with a lot of clients who are appreciating the fact that it can actually help them with some of these challenges as they are adopting machine learning and AI. Carmen, would you like to weigh in on that?
Yes, thank you, Aakanksha. And to build on what you just said, first of all, let's start with personal identifiable information. So we always ask our clients to remove that. So we make a request to, at the very least, mask it so that when the data gets to us, we don't see email addresses or names or phone numbers. So in most cases, that's possible. And the other thing is, just like Aakanksha said, the models can be tested for fairness because we do have the right IBM tools for it to make sure that whatever the model outputs is not biased towards, let's say, gender or age or some other protected groups. And in addition to that, every time client gives us data, we guard it. We safeguard it even from our colleagues. So we work in teams of 2-3 people, and it's only those 2-3 people that see the data that's already pre-processed in the sense that the PII is removed. So we work with that data, and once we finish the engagement, we delete the data from our laptops. Not even our manager sees it, because we are the custodians of the data was given to us. So basically, we're the ones processing it, and we only gather information that we need to know strictly for model building. So I hope that puts your mind to ease. And of course, we do have other ways of IBM protecting the data, but in our practice, that's the most common use.
Yeah, I think it's a very interesting approach, right? Is that sort of the discipline goes into that, and building that trust into the AI and the data collection just in general as a process. So a question is, and we have one question from the audience saying that, how do you deploy the model in the MVP process? So when you're trying to sort of build this model, right, and then you approach it, you obviously train it, and then you need to sort of test it on the real data besides your regular model building and the model testing approach. So how do you actually deploy that model in the MVP, given that you're trying to do it fast and sort of in the dirty way with the maybe not enough data that you would go for the big enterprise one? So how do you balance this sort of MVP is, and the more data for the model, the better?
Aakanksha, do you want to get started, and I'll chime in after?
Sure. So I think, again, I will try to break this down into a few points. As we go from a POC to an MVP, the idea is to just make sure that the model that we have built is fit for production. Because in POCs, generally, we tend to work with sample data sets. And the problems that we face when we build a POC versus the kind of problems that we face when we scale that POC to build an MVP is completely different. So once we deploy a model and we ensure that the deployment can deal with data at scale, we can then start to think about the next step that we need to follow. So as you mentioned, some points like retraining and redeployment and just the general model management process. And that's a fair question. I think once we have a model running in production, we can go back to the development environment and we can continue to fine-tune the models that we've built. And we can test them again in that development environment. And once we have made enough changes, maybe we added new features. And now that we've tested that, we are sure that it's good in the development environment, we can then redeploy it and replace that previous deployment with this new one, which can then work with the new data. Some things we do need to keep in mind is if we change the schema of the data between the first and the second model, then the schema will change in the downstream application. So there can be challenges around that. But in general, the steps should be as iterative and small as possible so that we can just checkpoint success at each stage. Carmen?
Thanks, Aakanksha. And to continue her thought, so what makes the model ready for deployment? So first of all, we take the algorithm and try to streamline the process. So quite often we work in multiple notebooks just to experiment, to come up with a proof of concept to prove in principle that this whole idea is viable, and it gives us the predictions that we're looking for. But once we have the procedure in place, then we have a second look at our workflow, and then we can automate the process. And that quite often it means writing a totally new notebook from scratch, where you just take the ideas of your previous notebooks and you just clean up the code in such a way that it does it automatically. And that's the first step. And then to Aakanksha's point, once the model is put into production, so it's deployed and new data comes in for scoring, you may notice that 3 months later, your model performance degrades. And that's actually normal because companies change their strategy. So for instance, if you have a telecommunication company, new data that may be coming in 3 months down the road would be a change in the plan of the customers. So all of a sudden they consume more data that they didn't have before. And our model will see data that will go out of range compared to the previous data that we had before. So that's going to skew the predictions, and you're going to think, oh my goodness, my model doesn't behave properly anymore. So in this case, you need to retrain your models on the new data that comes in so that it learns from these new patterns it sees in the data. And there are many other little things that you need to consider in production, so we can have a separate discussion around it. But we do have the tools to support all phases, proof of concept and ethics that we discussed before, deployment, and then check for drift in the model and redeployment. So we offer end-to-end solutions.
So let me maybe combine the second to last question into one. So you, as a part of IBM Elite team, just working with the different clients and the different processes. So two questions about it. So how long is usually your typical engagement with your client? But also, you being data scientists, you being scientists in general, right? How do you actually sort of decompose AI so people shift their thinking from that sort of very scary, very buzzy word out of the black box to something that is understandable, something that business can dissect, and something that business and the ROI in general, leading to my last question, can actually be built upon?
That's a great question. And actually, I'm glad you're asking, because what our clients need to know is that we work with them. So we engage them from the beginning in this proof of concept. That means instead of building it for them, we build it with them. And that enables them to see what happens to the models and to the whole process as we go through the engagement. So they're hands-on with us. And they participate in the feature engineering, they participate in the model building. Then we check to see the importance of the features. So we always look under the hood. We put them to work in a certain sense, but they love it. So we're always there showing them that, look, this is not magic. It happens for a reason, and this is the mathematics, and here are the visualizations, and here's how we can gain more insight. So by the end of our engagement, they're actually comfortable with the process. And we're only part of this process because we only do 6 weeks engagements. So after we leave, we have another IBM unit that comes in and continues the process, and they actually deal with deployment, operationalizing, and then coming in later and checking the models for drift and retrain the models and help the client down the road. So there's more than one IBM business unit that can help the client. We're helping with the proof of concept, and we're there from the beginning to assure them that what we're doing, again, is not magic.
No, that's I think that's kind of both a better good thing. Are you better paid when you're a magician or when you're a scientist, right? So I think I think that's also a dichotomy of the of real advanced science. So maybe the last question, just being cautious of time, and I asked the previous speaker about that. So what do you think is the right way to maximize the return on investment for the artificial intelligence initiatives?
That's interesting. Aakanksha, do you want to get started, or should I start again?
I can take a stab at it. So I think there's no one best way for it, because a lot of different things can work for a lot of different teams. From our practice, we have seen that there is a lot of value in just doing proof of concepts. As Carmen mentioned, we do a lot of things, and it sounds like a 6-month project, but we actually do all of that in 6 weeks. And in those 6 weeks, we work with the client day in and day out to understand their data, build some models, and show the value that lies behind all of these machine learning and AI algorithms. And after those 6 weeks, they see the value for themselves, and then they want to do more with that. And for me, I think that is one of the best ways to get some good, quick return on investment with the AI and machine learning.
Right, and to add a little bit to that, usually we try to quantify the return on investment. So quite often it means reducing the number of hours a data scientist works on a project because we're offering a technique that maybe speeds up the process, or we're reducing costs for a company because instead of going out, sending a crew out in the field to repair antennas or something in the network that's not working, we can save them money by predicting which networks are going to fail and where. Also, we can help with revenue optimization. And of course, we don't have to comment much here that we would be saving the company money by being able to optimize on the revenue by having some forecasting techniques where the sales would go, where the warehouses would be depleted first, and how to restock the inventory. So it depends on each use case. Usually we try to find the metric that we can use to see if AI would give them better return on investment.
Yeah, perfect. Well, Carmen, Aakanksha, thank you so much for joining us today and sharing your vision from science and magic perspective, as you depending how you want to phrase it. But thank you so much for dissecting this process. And I think that one of the questions that participants ask in the beginning is that how do you actually dissect it? How do you dissect this very big, scary AI word in the steps that could be done? And I think what you were able to show is to show that there is maybe some magic baked in, but in reality, it's the steps that you need to take, and it's, as everything, it's almost a process, right? It's only so much science and then so much art combined. So thank you so much for giving that very valuable perspective. Thank you so much.
Thank you for having us.
And thank you to the audience for attending our session.
Yes, heartfelt thanks to the audience for attending and bearing with us. Sure. So thank you.
Thanks so much. All right, so that's we already sort of through the half of our program. So right now we're just gonna take a quick 5-minute break, maybe make it 1:27, 1:28, just a quick 5-minute break, just to grab a cup of water. And our next speaker is going to be John Parello from Cisco. Again, very interesting conversation. He's corporate strategic innovation expert at Cisco, and we're going to talk about scouting groups and how you can dissect different AI initiatives into something achievable. So let's take a quick 5-minute break. I'm just going to play a couple of videos in the interim, but feel free to leave, grab a cup of liquid, and we'll see you back in about 5 minutes at 1:27 p.m. Pacific time. Thank you so much.
Hello there. My name is Andrei Kudov, and I am the founder and president of Silicon Valley Innovation Center. I've started this company about 9 years ago with a single mission to connect the large established companies from all over the world with the local innovation ecosystem of Silicon Valley. We bring executives from all parts of the world to Silicon Valley to introduce them to new technologies, innovation, and opportunities to transform their business in some incredible ways that they would never think about before.
Being here and having gone through the program with you and meeting all these companies, we actually see a lot more of the details involved.
It's a new way of thinking They gave us some insight.
I was really impressed how fast is blockchain getting into the industry and how useful it's going to be.
And how we can drive this digital transformation in our company.
There are a lot of opportunities out there.
An unforgettable experience.
It was nice to see companies come in and sit down with you and literally, how can we help you?
We can actually take a lot of these key learnings, these real details, real life situations, and try to synthesize that into something that would work in Vietnam.
So if you want to understand how your business is going to look like 10 years from now, what kind of technologies you would like to use in order to transform your business, let's connect and talk about how Silicon Valley Innovation Center can help you and your company.
Hi, I'm Kappa Lenkov, the Chief Science Officer here at Silicon Valley Innovation Center. As part of my job, I meet startups doing amazing, groundbreaking work. These young enterprises will one day lead their industries, and I want you to meet them. Our Startup Scouting Service uncovers the world's emerging technologies and promising early-stage companies. We employ top PhD-educated researchers and engineers from Silicon Valley. They dive deep into portfolio companies of venture capital firms and startup accelerators, and use business databases and other primary sources of data on emerging companies. Don't wait until innovators are disrupting your business. Find them today, partner with them, acquire them, or become their client. We use our extensive experience and networks to find the opportunities others fail to see. Our startup scouting services are tailored to your company's goals and ambitions. The startups of today are the industry leaders of tomorrow, and your potential partners or competitors. Connect with us today. It's time to meet them.
Our next speaker is John Parello, who is a principal engineer, corporate strategic innovation group at Cisco. John is leading the development of new products in network, telephony, wireless, energy, and lighting management at Cisco. He currently oversees the engineering of Cisco worldwide portfolio of innovation projects and is experienced in creating cutting-edge technology, lead it to market, and present it publicly with success. So, without further delay, I'm switching over to John Parello.
Hi. Well, my name is John Parello. I am a principal engineer at Cisco, and I'm here to talk to you about AI strategies and return on investment for your projects in AI. I'll tell you a little bit about myself, my background, the group that I'm in at Cisco. I'll go over 3 strategies that I think are good for AI projects, and then 3 sort of helpful tips for maximizing your return on investment, and then more strategies about how to define what your return on investment is and what it is for you. And hopefully then we'll have a good discussion at the panel. We can discuss some of these things, and we can take the topic from there. So let me quickly share my screen so I can do the obligatory PowerPoint to sort of guide us through the conversation. Innovation Labs. I'm part of our emerging technologies and incubation groups. And our group has the pleasure of working on trying to incubate new businesses. We try to look for bold bets and ventures that might be out of the comfort zone of the company and try to see if those are things that we want to work with. And we do that by co-innovation, and that co-innovation is with our customers and our partners. So we'll try to find new business ventures with maybe an entrepreneur in residence program or some sort of a bold bet or venture that came from our employees or our customers. We'll find those, we'll try to rapidly prototype them and take those ventures and iterate through them. And as part of that, I run the Innovation Labs. That's the group I have the pleasure of running. And our labs are located around the globe. We have 9 centers in as many cities. And we're located in cities where we have innovation centers. Our center and the labs are where we try to innovate ourselves, and we're trying to do new things. So my team will work in those different locations in the world. And we try to pop those up anywhere we can. So if there's an opportunity in South America and we need to be in Chile, we'll stand up a team there. But we might have a long-running team in just, say, Barcelona or London or in Singapore, and we'll have people that are dedicated to running the lab venture teams that I run. So that's a bit about myself. I've been at Cisco quite some number of years. I've worked on just about every one of our management programs, on the wireless platform, the switching platforms. And again, I have the pleasure of working on the Innovation Labs. So what I'm here today to talk to you about is AI strategies, some of the strategies that you can use, and how to measure and look at your return on investments of your AI projects. And so I'll talk about the without some takeaways. So I'll try to give you 3 things that you could take away about your AI projects. And these are some of the strategies that I have found help. The first one is saving everything. Data is important. The second one is scouting, having fast teams that can go far quickly and try where all the holes and all the things could be in a project, and to come back so that you could take a bulk of your team and then go the distance and then try to make a business or try to disrupt yourself with that. The third is partnering and working with your internal stakeholders, your external stakeholders, and getting the feedback that you need as quickly as possible to find out about your ventures and the projects that you're in. And these are general things that you could do with any venture, and they're particularly important for AI and ML projects. For things that can give you exponential growth if done well, but they can give you exponential problems if not executed well. So having this sort of framework for it in these 3 areas is something that I use as my guide through it. So let's talk about saving things. I said saving things is really becoming a data-driven culture that loves artifacts. In any agile process, part of it is to have your artifacts of your process as these coming through, saving that information. Every comment, everything could be saved. Any kind of information that you would normally say, oh, it's just something that we entered or something that we just collect data. Become a data-driven culture, because the data is what you need in order to succeed with anything that's going to become machine learning or artificial intelligence. And creating a culture where data and the decisions that you've made are retained somewhere and hopefully annotated. If not, it will be annotated. And sometimes the negatives are just as important. It's just as important. Why you do something is why you don't do something. Maybe those are something you want to revisit. So both sides of data are important. The things you're trying to count, and then the things you're not trying to count. So becoming that data-driven culture is something that's key to doing any kind of AI ML project. And that's something we can talk about with the panel. Then, as I said, scouting, creating a small team where you could try out a project and look for the benefits that you can, and have your scouts go out quickly, just as fast as you can, come back so that you're making the investments the way you want. Artificial intelligence and machine learning are sort of the gasoline that you pour on the fire of a project. And when you pour that gasoline on the fire, you want to make sure that you know what's going to happen when you do that that you have the wood behind the fire, the data, that you have the scouts on it. But just as important is partnering. Your internal stakeholders and your external partners are the people that are going to be basking in that fire, and they're key to incorporating what your business needs are. So having those partners, asking why and for what purpose, and we'll see how that helps with your ROI, is key to it. So saving data-driven culture is very important, high-level strategy. Scouting teams to try these things out quickly as the technology matures and changes, and partnering with your internal and external stakeholders to make sure that that you have the reasons for why you're doing the business. Okay, so with those three things, let's talk about the return on investment. When I hear ROI, I'm an engineer, I think metrics. A lot of times people say, okay, well, I invested some money and I want to see the return on it. I've sent the money out and I want it to come back with as fruitful and more with it. But what it really means is the metrics. And the metrics are the same for any kind of innovation. And are you getting the volume of work, and are you getting value from that work? Sometimes the volume is just as important as the value. Measuring something and say, hey, I did that project. Did I get the return on it? Well, what are the odds of that project going well? If it's 1 in 10, you're going to have to get very good at getting rid of 9 projects. But you have to be ready for that exponential change that's going to come from these projects. And the metrics for doing that and returning the value, how are you going to make sure that you're measuring the right thing? Well, you have to know the purpose of your business. If the purpose of your business is to invest money and come back with some sort of interest payment on that, then you have to know that that's the purpose. That's what your AI and ML project should be. And it has to be aligned with the purpose of your company. So for example, Cisco's purpose is to connect the unconnected. So anything we do has to align with that purpose. We can work on anything we want, but it has to increase that purpose. And by that increasing that purpose, we're getting purpose, you won't know what the proper return is. If the purpose is to increase the company for a period, might be to increase your customer base, you might not be as worried about the return for each dollar you put out on there. So you're going to say, okay, well, I'm increasing the base, I'm getting the return I want for it. And the last thing I always like to touch on when you're looking at that is ethics. Put that in here with the return on investment, but it's an area that you have to think about. Why not only you have to look at the project you're doing, is it aligned with the purpose of the company, but then should it and could it be done? Even though you could do it, should you be doing it? And one example I always like to bring up is when I was younger, I was working at Morgan Stanley right out of school. There was an older gentleman there who was the company evangelist. He was in his 80s at the time. And he had, as almost a child, at 12 years old, worked for Morgan Stanley. And he spoke to us and he said, look, things are going to come, you have to decide if what you're working on is ethical. The best, he said, was, if I can't brag about it to my mother-in-law, then it's wrong. And it's that simple litmus test that he has. He can't brag about it to his relatives or someone, and then he knows it's wrong. Same thing with AI. What you could do then with AI is, anything that you're doing is personify that system. Make it a person. It's Bob from accounting. It's Betty from HR. And that system is going to have gasoline poured on it and executed at a higher speed. And you have to say, well, it feels creepy and inappropriate for a person to be doing it. It's going to be even more so when a machine is doing that. So if you're going to say, hey, Bob from accounting is going to be going through everyone's emails and he's going to be looking for investments or things that we have missed, you have to ask yourself, well, hold on, what's the retention? What's Bob looking at? Is it going to be used some other way once Bob gets that? If you put a person on it, you say the person is not doing it, then you know you shouldn't be doing it. So to summarize, let's go back. Save everything. Become a data-driven entity. Every single thing that you're there. Just become like your grandmother, saving every photograph or anything you ever had, because you never know when you're going to need it. Having a nimble team that can scout and run out and try these things out, and partners who are going to tell you, yeah, this is good, this isn't good. And these are the things that you need for any kind of the projects, because these AI and ML projects can execute and amplify quickly, and you have to have that mindset of, is this what I should be doing? Is it for the customer? Is it what I should be doing ethically? And does it fulfill the purpose of the company? Don't just do something because for the sake of, I can do it. Just because I can learn about it and execute on it doesn't mean you should. has to line up. And those are the projects that I found are successful. When you have the data, you have the fast teams where you can bring it off of, then you could look at the ROI of that project and say, yes, it fulfills my purpose. It fulfills my purpose ethically. It's something we should be doing, and we should be going on. So I hope that helps. That's how we organize ML to make sure that we're long. So thank you, and I look forward to speaking to everyone on the panel and to answering any questions and further. So again, thank you very much.
All right, so that was John Parello of Cisco. So without further delay, we are switching to John, and we already have a couple questions coming in.
Hi, everyone.
Hi, John. Thank you so much for this very, very interesting, very action-packed presentation. And we already have several questions coming in, and maybe starting with your first thought that you had in your presentation, saying about the data collection. So where do you draw this line? Where do you sort of see that some data becomes private? Where do you draw this line, and how do you sort of negotiate, almost so to speak, to your customer community about data collection, data retention, and data protection?
That's an interesting question. Thanks. A lot of it is dictated by law. If you're in the EU, if you're in Germany or in the EU or anything like that, those things are very clearly lined out for you, what you can keep, what you can't keep. And when those regulations are in place, it's quite easy to form along those regulations. It gets a little bit trickier when you're in the US or something like that, where you say, well, you have to draw the line yourself. Obviously, let's just assume you're getting everything ethically and you're getting all the information that you can. It depends a phase on what you're at in your AI journey, because a lot of people are just doing the discovery, and then later they're building it, and then they decide to scale out. And then after you scaled out, you're getting your organizational learning and you're starting to actually reap the benefits of it. I think by the time you're at the point where you're starting to scale, you can then make decisions on, well, I might need this data, I might not. But while you're discovering and building out, it's really almost like I was saying, save everything at this point, because you don't know yet what you're going to need. It's just a case of practicality. But at the end, after that, if you don't need it, if it's not something that would become creepy to keep, then keep it. Let's put it that way.
So how do you define that creepy part? How do you actually do you have some kind of data stewards that maybe kind of looking, okay, we collected maybe too much, or that from both ethical and legal perspective, maybe people shared something that they were not supposed to share or anything like that? Because I think that the data ownership is a little bit gray zone from the legal perspective. Are you liable, for example, if somebody provided some data that is
exactly? Yeah, I think what happened before was data was always IT departments. The CIO owned the data, but now you're looking at it the business side has to own it, and then it's a business side decision that has to happen. And once you get in there, the legalities of it and retention policies and all that come in. Because before it was just up to the IT people. It was like, hey, you know what? I'm going to collect this data. I'm going to keep it because I need it to do this programming or whatever app I'm building. And now it's a business problem. So now it has to go to the other side of the house. And that's where that partnership has to come in. Your internal stakeholders have to be there. Cisco, we have a voluntary ethics committee, AI ethics committee group that go in and then keep track, and they can give opinions on that and ask people what do you think and that. So depending on your size, there are different ways to do it. But the data switched from IT to business, and now the business has to decide, not just IT.
Yeah, I think it's really interesting how it's one of those things where technology is really sort of driving the business. It's usually a lot of times business can be supplemented by the technology, but I think in AI and some machine learning, you can find ways to capitalize and sort of finance your new ventures and new products in the ways that were not possible before. So really technology becomes sort of a business thing rather than a support thing to the main business function. So very interesting question about the breaking down, sort of kind of piggybacking on what you said. So which would be the minimum realistic first investment for developing and launching an AI powered business? So let's say maybe AI powered division in your organization. So what do you think is the first realistic and minimum investment? Both maybe in terms of money and maybe in terms of technology, in terms of people that you get.
I'm going to give a standard Cisco answer on that one. It depends, which is also that's one. That's really hard.
You stole it from the Wall Street. You stole it from
Wall Street. It depends, man. if you're a small company starting up, it's very different than if you're a 70-person company or a 40,000. So I don't know, take a guess at framing, give me a frame of the type of company and maybe I can answer that.
So let's actually take, I think, two examples, right? So the first one is to say that maybe not necessarily a startup, but maybe some company that already got some traction. So maybe let's say, medium-sized business, let's say 70 people. And then let's look into the bigger organization, let's say 30,000 people. So let's take two.
Yeah, I think if you're a small company, then you have to think about whose data you're collecting. Are you taking the data from your customers, or are you taking the data that's something that's generated from your partners or the natural point to the business, right? So, I mean, Apple comes to mind, where Apple always says okay, we sell a product, we're not going to exploit the data that comes from the people. That's their standard thing. So they have to decide what kind of company you are. Are you trying to be a company that says, okay, I'm giving out something of benefit, and people are giving me the data, and that transaction is okay. So now you're okay, I can use that data, right? If you're a larger company, then it depends on your stakeholders, right? So if you have a 30,000 size company, well, I'm assuming you've got customers and partners. So now you have to say, okay, does that go against what we're doing? Is that line up with what our partners are expecting? That's the difference on there. So you have to see where it's coming from.
Yeah. So there was actually a specification. So if we're talking about the legal tech company in that smaller space, so how
yeah, it's very specific.
Yeah.
So you're a legal tech company. So you're a tech company getting in the legal space. Wow. I mean, if you're a tech company getting in the legal space, you better have some good advisors telling you on that. So I'm going to defer to your corporate team and your board on that one. You better have some good ones if you're a legal tech company. That's going to be hard in the legal areas. It's very tough. I mean, what's interesting about the legal areas is there's a lot of things that can be done for rules, like doing contract negotiations between, if you're doing a tech company that wants to change the contract negotiations between unions and labor or something like that. Well, AI could be used to look at the rules and see, is there anything that's that doesn't make sense, this could never happen, or these are, there's a lot of things you could do to adjust that data. But then when you get into specifics of the data of a specific contract, you got to go with the experts on that one. Yeah, I don't know if there's much I could add on that one, but stick to the experts on that. But the rules processing is something that you could do, because the legal field is just filled with rules. And the classic thing is people put laws through AI engines and they find all the inconsistencies right away. Which we never even saw before. That's the classic one, right?
Yeah, definitely. So what about big organizations? So let's say that you're already sort of incumbent and you have been around for quite some time, let's say 30,000 people, 10,000 people. How can you sort of bring AI, and what would be the minimal investment when you say, okay, we want to be AI, we want to take it. What would be sort of the minimal, maybe first step on doing that, and how do you actually balance? Do you create dedicated team? Do you create a chief AI officer, or what do you think is a better approach?
I'm always of the opinion, that's I talked about with the scouting. I'm always of the opinion of saying, it's better to grow a team than it is to go and finance a team in a big company. It's better to grow it and get momentum. So take a small team, right? Attach it that has the AI capabilities and has that knowledge to do it, and then see if they could run and get benefit with somebody. And when they do, add more and more fuel till they grow. It's that pioneering thing. It's just a few people to do a path, and then a couple of settlers, and then a few more. And then when it gets to the point where you could build a city or something in that area, okay, it's fine. But small scouting parties is the way to go, right? And then see if there's value, test it, and then come back. So I'd say the minimal investment you could do is just a small independent team that has a lot of the expertise, and then they can go and attach themselves to the projects and see what they can do and where they can have benefits. And I would go for my biggest pain point right away. I would go and this is an area where it's our biggest pain point. I'd send them into the roughest road that I could find and see what they can get.
Yeah, that's I think a very Silicon Valley kind of approach, just trying to. And again, I think what you're saying, and correct me if I'm wrong, there is it depends, because there's so much uncertainty that you need to be comfortable with it, and you need to sort of first try the water before you put more resources and pull more engagement into this area. And sometimes AI will work in one area and they will be able to find some of the expertise, but in some areas it will not be possible. It will not be getting enough traction to justify the investment. But I think you brought a very interesting point about the smaller company, about the data, right? Because it's the main saying is garbage in, garbage out. But when you're a small organization, or maybe one organization that have historically have not been data heavy, so how can you actually start building that AI if you have a very limited data? I know that for some financial, you can buy the data, you can acquire the data.
Yeah,
but
that's where I was going.
yeah, but how do you actually start an AI business when you're not data heavy company that was not listening to you and were not collecting all the data that they might?
Yeah, that's a tough one. I mean, you can try for other training sets. Sometimes, it's like you want to go play. I hate sports analogies are overused, but you could say, I have to train. You don't have to train on exactly the same thing. Sometimes you could train on other similar data. So you might be able to buy data in a different area that's going to help your training. And then as you get some traction, you can go in there. That's one way. So buying the data, getting the data. You can kind of try to split it up too. I mean, people will give up their data if they find a value for it. So if you can't buy the data, you have to provide value for the data, right? And that's the thing you can do. So you might have to have two things going on. Here's my goal of where I want to attend, but I need some data in order to get it. Well, I have to build something else that's gonna give value to get the data. I know I'm speaking in very abstract terms, but you have to offer something up for people to give the data, and then it's okay. It's a poll, or it's like it's the same thing like when when pollsters were going around and saying, hey, I want to take a poll, or I want you to fill out a survey. Well, fill out the survey and you get a chance to win something, right? Well, people are happy to give. They're happy to give out their information for the chance to win something. Yeah. I'll give you, 10 people will, out of 10,000 will win something. And it's like, that's how, the marketing, gathering that data is the way to do it. You have to give up something of value to get the data and then use that data for the next cause. Yeah, and it's great when it all lines up. When it all lines up and it's all in the same thing, you don't have to go orthogonal to it.
Yeah, actually, a little bit different approach, but I know that several companies partner up with the universities saying, hey, we have all this data, especially for the asset-heavy ones, is that we have all this data, but we have no resources to process it, and B, we have no idea what can we do with it. And sometimes that partnership with the universities, who's hungry for data, who's hungry for real-world problem, might actually do a big difference in terms of going and actually starting something. So I think the other way my work as well is that we thinking that this is this, we have sort of some idea, some testing, we're just gonna do work for you for free. So the biggest risk that you're running is that you wasted 3 hours talking with us and signing a legal agreement because we haven't yet created the bot that will actually do this from the legal standpoint.
Yeah, you got to give something of value up to them, and then they'll get the information.
Yeah, definitely. I think it's super important. So just being cautious of time, I don't know, maybe last question or second to last question is that what do you think companies can do to increase their return on investment on the artificial intelligence products or in artificial intelligence-ish projects?
Again, that's what I was talking about before. The return on investment is depending on what you're trying, your purpose, right? So if your purpose is to gather the information, you're saying, okay, if my purpose is to collect the information or I need the information to monetize it, then your return is more information, right? If your return is, well, I'm going to finance a X number of tens of thousands of dollars on a project and I want to get X number back, that's a completely different calculus on there. So I know it sounds like I'm dodging it a bit maybe, but it's hard to say, your return is what you're looking for, right? So in a large company, the test is always, I put this many people on it, I expect to make this much money per head on this. Am I getting the value out of that? It has nothing to do with AI at that point. It just has to do with the project management of that. And all studies and things that are coming out from like BCG and Gartner and things like that is that the biggest portions of the AI projects are not the technology. It's the people in the process that are in there. And BCG said something. I think the numbers right. It was like about 70% of it was the people in the process, not the data and the technology. So if you don't have something where you can run. If you're not running your project and maximizing your people, the technology is not going to matter at all, right? Like you could substitute anything in there in for it, but the people and the processes are going to matter. So you have to make sure you're doing all the kind of design thinking that you could, where you're embracing failure, you're moving quickly, minimal viable products, so that the people are working on the projects and you can fail fast and move through. So all those other practices matter just as much for AI, right?
Absolutely, yeah, and that's actually something that I've been repeating over and over again, is that as AI in a lot of cases is just a ability to work it at scale. right? Is that if it works on the paper, if it works with your people and your processes are ready for that scale, then putting AI on top of it definitely makes sense. And I think, and I think also, it's also interesting to see that I think, correct me if I'm wrong, based on your experience, that right now it's so almost cheaper than ever to start those new projects. Because what we failed to mention in terms of data acquiring, there's so much of the public data available. I know that Google has done a lot of NLP stuff, natural language processing. There's so many databases everywhere that could be used to start list something and see where you can do different things. Just if you have an idea. And I think that ability, right, saying that you can actually do cheaper, you can acquire technology, you can acquire processing power, you can acquire data cheaper than ever before. I think that's something, a mentality that is shifting, and probably, especially in 2020, people realize that we don't even need offices to do stuff, right? We can actually do it ourselves. So I think it's important.
It's a good point. So at the risk of dating myself or something like this, but if you look at the same question, if you go back the clock to the 90s, people are going to ask the same questions like, how can I use web services in order to optimize my business and this? Well, I mean, think about it. If you don't have a good supply chain, putting your commerce online with a web server, it's not going to help you if you can't do the fulfillment, right? So the fulfillment is 70% of it. And so the question you're asking, if you just substitute in there everything you just said and turn the clock back and say, web services or browsers, or how can I set up a website to increase my capacity for the people? It's getting easier now because Apache has got these things that can go up really quickly. Yeah, it gets easier and easier to put the technology out there, which means you have to rely more and more on the people and the fulfillment and the back end of this stuff than it is on the technology, because it's super easy to do, right? Beginning of setting up a web server, only a pure geek could do it. You had to do it in your basement and you were the only one doing it. And then it was everybody and their grandmother can set one up, right? Same thing with AI. It was like, well, it was hard to do it, but PyTorch and things, it's super easy now, right? To do these things. It's getting in the hands of everyone, and we're at the scale phase of this, which means I'm going to worry less about the technology and more about the people and the process behind it that it's enabling, because that's where you're going to trip up and fail over.
Yeah, definitely. All right, John, just being cautious of time, thank you so much. Always a pleasure to speak with you. And thank you for really breaking down some of the very complicated things. And I think it's one of the things that a lot of companies need to understand, is that, yes, Silicon Valley has the knowledge. Yes, we have a very experienced people who did it, but nevertheless, all the business problems are different. So nobody going to give like a cookbook. It is more of the guidance. And I think that you gave a fantastic approaches to structuring on the larger team and building the strategies to increase that ROI that we have been talking about. So John, thank you so much, and have a wonderful rest of the day.
Thank you. You too. Thanks.
All right, so our next and last speaker is Patrick Biltgen. So he's going to be from our sponsor, PERSPECTA. So please do stay after his presentation just for a little bit longer to feel a last interactive part of our presentations, and be on the lookout for that survey from us. Answering that survey will enroll you in a chance of winning one of the 3 free tickets to our Leading Digital Transformation program that starts on November 30th. So our last speaker is Patrick Biltgen, who's the Technical Director of Analytics at PERSPECTA. As analytics offering family-led at PERSPECTA, Patrick leads research and development efforts for machine learning, artificial intelligence, modeling, and Internet of Things. Recognized for unconventional ideas and unique perspective, Biltgen is a thought leader who has supported data fusion and modeling efforts for multiple intelligent clients. A prolific writer with a reputation for explaining complex material clearly, Biltgen published Activity-Based Intelligence, Principles and Applications, the first unclassified textbook on this contemporary intelligence tradecraft. In 2017, he was awarded the Neil Armstrong Award of Excellence in honor of his professional accomplishments and passion to expand the boundaries of exploration through science and technology. He volunteers with the Astronaut Scholarship Foundation as a member of the Strategic Planning Task Force. Biltgen holds a bachelor, master's, and PhD in aerospace engineering from the Georgia Institute of Technology. He earned the SFE Agilist certification. So, without further delay, I'm switching to Pat.
Hi, I'm Pat Biltgen. I'm the Director of Analytics and Data Services at PERSPECTA, and I'm here today to tell you about some of the AI challenges for adoption at scale. First thing I'd like to introduce you to is a concept called statistical machine learning. This is the dominant way that many AI models are done today. It's a very popular approach to making AI models based on complex regression of data. And one of the questions that comes up here is how accurate are these approaches? And in one example that's shown here, this is an example of an algorithm developed for DARPA where they looked at building algorithms that could do scene understanding and description. And here it says, a baby is holding a baseball bat. Now, when you look at this, you go like, it's kind of close, but it's not really correct. And that is one of the main challenges we see now, where it's the phrase that DARPA likes to use is statistically impressive, but individually unreliable. You can always find a couple examples that give you unease about how the algorithm is performing. Now, AI generally performs well on easy problems, but in most problem domains, all the problems are hard. In this example, this uses pre-trained imagery from a very large data set called ImageNet. And if you look at the top of this image, these are the easy classes. These are things like a tiger, where the tiger has very discrete features. But then in the bottom, these are the classes that are the hardest. One of them is a hook, and the image that's shown is like a hook at the end of a piece of construction equipment, not like a Captain Hook hook or a fish hook. And so objects that are more ambiguous are much harder to recognize. This is a big challenge in especially the defense, intelligence, and healthcare domains, because most of the stuff you're looking for is actually really hard to recognize against the background. And so when we see examples of, hey, the computer wins the video game, or it can tell dogs and cats apart, that's usually not the problem that we're trying to solve. Here are some additional examples of hard problems. One of my personal favorites is called Muffin or Chihuahua. This grid shows images of muffins and Chihuahua heads. And as you can see, some of them actually look pretty darn close. Like the one I put the red box around, you go, boy, that really looks like a sarcastic Chihuahua. This is an example of what's called a low contrast problem. The examples are actually not that different from each other. And a human is pretty good at detecting the nuance, but it's very difficult to train a computer to tell the difference. In the middle example, these are a pair of researchers that built what's called a patch attack. So there's a common person detector algorithm that will draw a box around a person, and they used a technique called adversarial machine learning to design a patch that is the opposite of a person. It basically is detected by the computer as having an object score of 0. When you print out that patch and hang it around your neck, your object score goes to 0, and essentially you're invisible to the algorithm. This represents a new type of stealth technology, or an invisibility cloak, to hide you from these algorithms. And the third example I'll show you is what's called explainable AI. In this example, an algorithm was used to differentiate between a husky and a wolf. And then when you ask the algorithm, why did you think that was a wolf? It says, because of this. And the thing it points to is the background. And it turns out that the wolves were often photographed in front of snow, and the huskies were photographed in front of grass or dirt. And the key feature the computer found was actually the background, not the animal. And so when you're training these algorithms, you have to be very careful that you don't set up the problem incorrectly. Another phenomena is called giraffing. Here, there are 3 pictures of giraffes, except the pictures aren't actually giraffes. These pictures have been labeled as containing a giraffe from a machine learning algorithm, but they're not in there. Okay, what's really going on? It turns out that giraffes are very rare, And if you ever saw one, you would take a picture of it with your camera and you would probably post it on the internet and say, hey, cool, it's a giraffe. But those pictures are usually also nature scenes or large open plains in Africa that have grass and maybe a couple cool looking trees around. So it turns out that giraffes are very overrepresented in image data sets. There's just a lot of giraffes in there. And if you train your algorithm based on publicly available imagery, you're going to have a lot of false alarms that are related to this phenomenon. That's an example of an object that is overrepresented in training sets. Another example that was popularized this spring is almost every AI researcher got their hands on a bunch of COVID chest x-rays, and they ran through an algorithm to say, hey, I can build a COVID chest x-ray detector using machine learning. So this is an example of one such tool that's online where you can upload the picture of an x-ray and it'll tell you how confident it is. In this case, it says the x-ray shown is COVID-19 with a 99.97% confidence. Well, unfortunately, these algorithms are very biased towards the training data and they tend to have a high false alarm rate. You know what I did when I saw this, right? I uploaded a picture of our friendly giraffe and just to see, hey, what would the algorithm say? And because of the way that it's trained, it says, hey, this picture, actually a giraffe, is a COVID positive chest x-ray with a 99.82% confidence. Poor giraffe. So you can't always trust these examples when they're looking at training data sets. They may be biased toward a certain type of sample. Now, the primary flaw in the examples I've shown is the selection of training data. This chart shows the way that training data is typically distributed. In this case, I mentioned the ImageNet data set up front. The ImageNet data set has about 1 million images in it. So if you divide your images into 80%, 15%, and 5% for the training data, the validation data, and the test data respectively, which is the rule of thumb that you would use, it turns out that rare events almost never happen in the data. You have about 3 Six Sigma or very rare events in your training set. So your algorithm only saw very rare things a couple of times. And your validation and test set actually contain less than 1. So you can't evaluate how well your algorithm does rare things. And so I use this to pose the question, should we really be using these essentially Gaussian distributions of training data where you have many things that are common and are at the median and not a lot of rare examples, or should we be biasing our training data towards the weird stuff, towards the things that you don't see very often? And I use this example in military and intelligence domains because if there's a war, we're almost certainly to see things in the tails that we've never seen before. And when you talk about rare diseases, you're always operating in the tails. And when you're talking about clever fraudsters, they're always hiding in the tails. And so be careful that you're not using normally distributed data when your problem isn't really like that. Now, one of the things in building up trust in machine learning algorithms is assessing the results and seeing how they do in real-world problems. This is an example of an algorithm that my team built to participate in a large competition of satellite imagery data. So just like ImageNet that had about 1 million ground-based images, this data set has about 1 million images of common objects, things like planes, ships, buildings, etc. But the problem is there's a ton of variability across the classes. For example, a plane might look like a Boeing 767 that's a large passenger aircraft, but that same class of plane also encompasses little things like Cessnas and F-16s and a bunch of military equipment as well. Buildings are all different sizes and they look different in different parts of the world. Some of the cars are actually parking lots that were mislabeled as car. So all of these things influence the accuracy of the algorithm. And as shown here on the chart, when I work with imagery analysts and show them this example, they always go to this plane right in the middle. And they go, in this example, the algorithm is putting a box around the things it's detected with a confidence. And they say, why does it put a box around this plane with a 99.9% confidence, but this almost identical plane in the middle is completely missed? And it's very hard for us to explain why the algorithm is doing that and why it missed so many detections in the image. And this is not very helpful when you're trying to build up confidence that the algorithm can be used to augment what the analysts are doing today. Now, we always say that more data is better, right? I train it with more data. That would be better. But there's a new challenge that has emerged here is that most of the data is labeled by humans. But we also know that humans tire when they do menial, tedious tasks like labeling training data for 10 hours a day. So my team set out to look at what happens if they mislabel the data as they get tired. We intentionally mislabeled some of the data in a data set called PlainsNet. And remember that planes, because they're large objects against a high contrast background, they're almost always detected easily. So this is pretty much the easiest problem that you could have. We mislabeled some planes as not a plane and fed it to the algorithm to see how it would do. We thought that if we mislabeled about 2% of the data, the error rate should go up by about 2%. But we actually found out that there was a very large change. In this case, the deviation percentage was much greater than what we put in. The algorithm was getting confused very quickly by the mislabeled images. And this doesn't give us a lot of confidence that very large human-labeled data sets are going to be accurate to produce highly accurate models in very serious conditions. Another phenomenon that we examined is the variability of slight input variation. This is an example that's done by some researchers at Auburn where they took the ImageNet data set and they performed some transformations where they essentially generated a 3D model of the objects in the image set and they rotated it. So while the most popular pre-trained image recognition algorithm in the world is about 99% accurate on fire trucks, if you rotate those fire trucks slightly, the accuracy goes down to about 3%. And this is very concerning. It says the algorithm isn't really very good at recognizing things that are taken off angle. Now, if we think about ImageNet, it's literally a data set of the most perfect pictures you've ever seen. It's like a really good picture of a fire truck and a straight-on picture of a cheetah. No shadows, no obscurations, no double cheetahs, no flipped-over fire trucks. And so the algorithm is biased to only learn about what things look like under optimum conditions. In another example, the researchers looked at then rotating these different objects and seeing how the classification changed. And the one that's most concerning to me is the one I put a red box around. This is one where you actually have a motor scooter in the scene, but it's misrecognized as a bobsled with an accuracy of 100%. Despite the fact that this is a scene that contains no snow, it's basically like a road in the middle of a city, the algorithm thinks that's a bobsled. This is the opposite problem of the giraffing problem. Bobsleds don't actually occur very often in the real world. It's a pretty rare object. And the fact that the algorithm would guess that this scene is a bobsled and then say it's 100% accurate is extremely concerning. It means that the data set, this model that many people are using for image recognition, is overtrained for a small number of objects that are in the data set and therefore could be guessing the wrong thing if it doesn't get a perfect picture. One of the approaches that can be used to combat some of the common problems in AI training is called fleet learning or auto-training. One of the most notable examples of this is the autopilot vision system in the Tesla automobile. The way it works is the cameras and computers are running all the time, whether autopilot's activated or not. And as the human behind the wheel stays between the lines, the computer learns those are lines and he's staying between them. As you avoid obstacles, if the computer thinks certain things are obstacles and you don't run into them, you confirm the computer's bias or belief that those in fact are obstacles to be avoided. So the beauty behind the way Tesla has created their vision system is they built a way to gather data from everyone that's driving the car all the time, and those people will encounter rare situations at the base rate they occur at in the real world. So instead of trying to design a training data set that would give you all the weird stuff that happens, they actually put us all into the training system and allow us to build that data as we're driving. Another very powerful example is a capability that Gmail rolled out called autocomplete. So as you're typing an email, the algorithms that are running behind the scenes are looking at the context of the email, like for example, to whom is it addressed, or when have you met with them before, and what could the subject be about. The thing I really like is as you're typing, it starts to complete the sentence for you because they have every email that anyone's ever sent through Gmail. And they know what keystrokes you typed before the sentence appeared. So you can build an AI model that says these keystrokes have a certain probability of resulting in this sentence, and that is enhanced by the context of all the other things they know about you and about what else you're saying in the email. So this presents a really interesting way of training the AI algorithms using the data that you have as people are conducting their regular workflows. And this is a very powerful technique that many businesses need to think about how to implement. How can I instrument the work that people are already doing to build AI models that replicate the work that they're doing? building that data automatically and at scale. So finally, just some tips to help with AI adoption. There's a big rush to try to build these models as fast as possible and roll things out, but sometimes they can be met with a lot of skepticism from the users. So we really need the time and space to question the way that we're using the data and the way we're making decisions. We need to train people in probabilistic thinking so that they can better understand when things happen, and the cultural awareness that things happen in different places for different reasons that may be tied to the people that live there. We need both red teams that question assumptions and diverse teams that look at solving the problem in different ways, or else we have a danger of being biased towards falling into a certain preconceived notion of the world that might not be right in all conditions. We need research tools to question the way we've done that, and models that know when they're wrong. A big challenge today is the model can't tell us when it's uncertain about its decisions. AI developers need to not just drink the Kool-Aid that the technology is amazing, they need to be skeptical of the things they've created and how they might go wrong. And finally, you build trust through time. And with continuous adaptation and experimentation, we can build models that people can trust, that can be applied to hard, real-world problems and address some of the challenges I've highlighted today. Thank you.
All right, so that was a presentation by Patrick, and we have Patrick on the line. So without further delay, Patrick, let me switch over to you. Hi, Patrick.
Good afternoon. How are you, Vlas?
Another day in paradise. Another day in paradise.
Great.
Thank you so much for that presentation. It was really interesting to see, and I'm still a little bit baffled for the term giraffing, but I'll try to think a little bit more about it. But something very interesting that I think is important in the applications that I think PERSPECTA faces, but also in general from the AI application, is that some people say that AI is artificial intelligence, and some people say that AI is augmented intelligence. So where do you think we are right now? And do you think that at the end of the day, maybe in 5 years, we're going to be slightly shifted more towards one or another?
Well, that's a great question. I mean, the term AI has become very popular also for many things that aren't really AI, right? Some of the things could be decision aids, some of the things could be statistical models, and a lot of it is machine learning. So I think the idea of augmented intelligence is a lot better. For example, if you can use historical data to improve the context of the decisions that you're making, or even get advice on how people in similar situations have made decisions in the past. Today, when we look at the driver assistance systems, they're not yet reasoning through the hard problems of automated driving. They're helping the driver do things like stay in the lanes and avoid running into things. I believe that for the next several years, the notion of augmented AI is the notion of augmented intelligence is probably a lot more appropriate, and that's going to help us build trust in those systems going into the future.
So what do you think actually sort of, maybe again, comparing now and the future, so what do you think is the ultimate trust from the business perspective that AI systems need to build for companies first to adopt it, and then maybe in the future, what do you think is that trust threshold that those systems need to reach so we switch from this augmented, and we're still making decisions, you're just helping us, to more artificial where its decision-making process is in the hands, so to speak, of the computer?
Well, today we still have that notion. You saw the example of the boy holding a baseball bat. And when the computer does something that is just really, really wrong, that causes you to question the whole thing. I do like the self-driving examples, but anyone that has been behind the wheel of one of those self-driving systems has seen it do something really, really stupid. And they are getting better. They're getting much better. We've seen examples of recommendation engines where it goes, I would never buy that. That's really, really stupid. So I think in the near term, when the computer stops doing things that are way outside what we feel we would do, I think we're comfortable with the fact that sometimes people don't make the best decisions. Like, I bought a bunch of oil company stock about 8 or 9 years ago. I said, they're going to do fine. Well, that maybe wasn't the best investment. But, I didn't buy stock of a company that was already out of business. That would have been a very stupid decision. So that's maybe an example of how we can start building trust, is not so much it has to be right all the time, but it has to be insanely wrong less often.
I think it's actually a really interesting approach, right? Because I think that AI, as you said, it's really built into sort of like statistics and ML, and as you said in your presentation, it is mainly focusing on the statistics, right? It has to be statistically right in the majority of the cases, right? So do you think that it's almost inseparable limitation of AI that those tail events are sort of not really processable? So do you think that there is still sort of there's still going to be sort of like this 1% or maybe 1/10 of the percent that AI just from the statistics standpoint just cannot predict, and we cannot really sort of like let it run loose with mission critical problems?
Well, many of the things that we're seeing today that are based on machine learning are exposing the computer to examples. So the examples have to exist. They have to be plausible, and they have to be at least calculable in the data set if you're going to use that type of approach. I think what we don't really have today is cognition, is that the machines aren't reasoning through something that they've never seen before the way that we would based on all of our past experience. And so I think there are research teams that are working on that. But today, the machine learning approaches, it's a little bit of a misnomer. It's not really learning. It's really massive regression of the data, right? And what it's really doing is it's remembering and it's interpolating between the things that it's seen. So I think until we get to the point where the unusual things can be reasoned through, you're not going to get truly to artificial intelligence. And some of the examples of that, by the way, and humans aren't good at that either. When we see things that have never, ever happened before, we get surprised by them. That's the phenomenon of black swans. I'm not sure if it's an attainable objective, either for humans or for AI, but that's an area where I think you're going to see a lot of investment to try to get to that generalized approach.
Yeah, a little bit more of the unsupervised learning, right? It's a little bit more of sort of like try and see how it is. So just being cautious of time, maybe the last question that I've been asking to all of our wonderful presenters is that how do you think companies can maximize return on investment by onboarding artificial or augmented intelligence?
Well, the best advice that I would give companies is think about how you define the problem that you want to solve. Sometimes when we, like I do a lot of work in the Intel community, and we want AI to go solve the hardest problem, like the mobile missile problem is always, from the 1991 Gulf War. It's like, where are the Scuds? Well, they were hard to find. There's a reason for that. So if you give it your hardest problem, like detect obscure cancer, it probably isn't going to succeed, but the humans aren't either. Now, if you give it a totally trivial problem and it succeeds, no one's going to care. So if you consider that as a two-dimensional axis between things we really need to solve that are impossible and things that we can solve that no one cares about, when we define problems, you have to be somewhere in that space. And I advise companies to start with problems that at least we know the answer to and work your way up that chain towards the harder problems. But if you start with the absolute most impossible problem for which we don't have any data or decisions today, you're going to have a very bad outing, and you're going to really lose a lot of faith in the investment.
Yeah, I think it's really important from the testing perspective, right? How we say in the validation and testing, it also goes not only for the data but for the processes in the organization as well. If there is no way to validate, if there's no way to sort of like test it, right, and do it on scale, because AI is at scale, it really becomes almost impossible task, and that's I think where a lot of that investment is sort of lost in inability even sometimes to recognize maybe you found something, maybe it's applicable, but because you don't have the business acumen and enough business knowledge, that you just losing it. So yeah, and I think it's a very, very good insight. All right, Patrick, thank you so much for this wonderful presentation, and thank you so much for answering the question from our audience. Thank you so much, and have a wonderful rest of your day.
Thank you very much.
Thank you. All right, so everyone, thank you so much for the attending, and I think I'm closing the end of the questions. So how about we do a very quick exercise? So go again to thementi.com, enter the code 91 68 25 and 9, and please enter 2 things that was the most impressive from the 4 presentations that you saw today, both in the negative and positive manner. Maybe you were saying, oh my god, we're collecting too much data, or something that you might found applicable to your particular business case. So if you can go to thementi.com, enter 91 68 25 9, and just give 2 ideas. Again, maybe short, very sweet ideas of what you have learned. So in the meantime, when I know that there's a slight delay between me broadcasting and you entering, so I think that very interesting to me was really to see into the different approaches that companies take and how we can look, right? We talked about sort of like almost technology less approach of finding the best accounts. We looked into the ways how IBM and their data lead team approaches the solutions. We looked from the Cisco way of doing things when we were focusing on building the strategies. And I think from the PERSPECTA, I think it was really interesting to see, not from the technical, maybe even strategy perspective, but looking into what can and cannot be done and some of the limitations that are built into this. And I think it's really important to understand what are the applications and how they can affect the decision-making process, and what are some of the limitations, and what some of almost the differences between augmented and artificial intelligence. So in the meantime, please go to ethics and accuracy. Yeah, I think it's really interesting from the perspective of accuracy, right? Because from finance perspective, and I have my background in finance, I think it was extremely important to understand that nobody's in finance is actually looking into the absolutely 100% right algorithm. Pretty much in finance, if you have the machine, if you have the model that is right 52% of the time, that's it. You just won your jackpot. Because if just being a little bit more right than being wrong in finance is all what you need, and then you can pour all your money on it and you're just gonna keep winning just by a little margin, and then you just add volume. But I think here, especially in the very mission critical decisions, I think that artificial intelligence and machine learning and machines really have to be right. And especially when we talk about ethics, when we talk about governmental use, when we're talking about maybe some of the suggestions, I think it's really important to be truly right and actually define that right and put the boundaries around what is right, and put the ethics limitations about, okay, when do we stop, and when do we sort of limit our drive to win better models. So I see that there's a lot of feedback coming in, so thanks so much. Again, if you want to go and add, there's a menti.com. You can just enter the 91 68 25 and 9. So great. Thank you so much for your feedback. And then last but not least, you can go, this is our feedback form. We're going to send it over. You can go and scan it or use it elsewhere. This is going to be our feedback form from this event. So I personally and all of us here in Silicon Valley Innovation Center, thank you for joining this wonderful event sponsored by PERSPECTA. We're going to have next event next month. So if you want to attend a similar format of conferences, please stay tuned. We also going to send the feedback form as well as the presentations of our speakers, so you can review them. And please do fill out those forms, because we going to distribute 3 free participation in our leading digital transformation program by Silicon Valley Innovation Center, connecting you with the top minds of Silicon Valley for your organization. So thank you so much for joining this event today. My name is Vlas Lezen. I'm Chief Operating Officer at Silicon Valley Innovation Center, and have a wonderful rest of your day from everyone here in Silicon Valley Innovation Center. Thank you so much.